So this lesson is going to be all about polynomial inequalities, and we're going to go through about 3 examples of how to solve polynomial inequalities. Let's start with just a brief definition here of a polynomial inequality and maybe what it looks like on the graph we're going to check out there, and then what it looks like when you're reading it as a function. So a polynomial inequality is an inequality that can be put into one of these forms. So we have a function, polynomial function f of x, and then we know inequalities are the less than, greater than, less than or equal to, greater than or equal to. So we just have to make sure everything with the function is on one side of the equation, and then we'll get everything to one side, and then we'll have 0 to the other side of the inequality. And that's what we want the form of a polynomial inequality to be in. The main thing when we go to solve, and that's what I want us to look at with this graph here, a little bit, is when we have a function and it's greater than 0 or less than 0, what we're really interested in is looking at where it intersects the x-axis, because that's where 0 is. That's where the function is 0. And so if we're looking at where a function is greater than 0, greater than 0, that's everything above the x-axis, okay? That's everything, that's all that whole blue part of this graph. This is the interval where this function, x squared minus 7x plus 10, is greater than 0. And when we go to solve the examples that we're going to do in this lesson, you'll notice our answer is an interval, okay? So for this problem, the answer where this function is greater than 0, we're looking at this interval above the x-axis where we are greater than 0, and we can say it's everything from negative infinity all the way to these x-intercepts, which we call boundary points. So this is just an example of what our answers are going to look like in the examples we're going to do today. And then we also have it's greater than 0 from 5 to infinity when we write that in interval notation. And so just to kind of give you an idea of what our answers are going to look like, they're intervals. We're interested in where this function, it's like a location, where this function is greater than 0, or where this function, this polynomial, is less than 0, and that would be this purple region. We would say it's less than 0 from 2 to 5. And that's what it looks like graphically. Obviously, when we do it algebraically, it's going to be a little bit more challenging, not as easy to find our answers. And so on the next page here, let's scroll down. We have the steps on how we solve inequalities, and I'll give you a moment if you want to jot those down. How are we going to find that interval where this polynomial is less than 0, greater than 0, whatever? The first thing we want to do is solve the function. We'll solve when the function equals 0 to determine those boundary points. Those boundary points are your x-intercepts. So we'll solve the equation to find the zeros, like we've been doing in this course already, to find the zeros, x-intercepts, boundary points, all the same thing. And then we make a little number line and plot those boundary points. To then, in step number 3, we're going to complete a sign analysis using the factored form of f of x. Factored form is easier. We can use either the factored form or the not factored form, standard form. Factored form is just easier. And then this way, we can use our sign analysis to graph and write the solution in interval notation. And we'll work through those steps in 3 examples that we're going to go over. We'll start in a moment. Let's get a chance to copy the steps down. And a sign analysis might be unfamiliar to you guys, so I will be sure to go through it in this in these examples, so you'll be able to see what a sign analysis is. Okay, so let's check out this example here. Solve the polynomial inequality and then write the solution in interval notation. So very first step we want to do is get that function equal to 0, and then we're going to solve it. So we're going to get everything to one side of the equation. I'm going to subtract the 15 from both sides. So we will have 2x squared plus x minus 15 is greater than 0. And now we have to solve that for x, okay? And we can write this equal to 0 just to think about solving this. And we should be very familiar how to solve this. It's quadratic. We will have to factor. Do whatever process you need to do to factor. When I have factoring when a does not equal 1, I do factor by grouping. So I start by multiplying a times c, and I make a little chart over here. I do negative 30, that's going to be, and then my b term is 1, and I need two numbers that multiply to negative 30 and add to 1. That's going to be negative 5 and 6. So I'll factor by grouping. It'll become 2x squared minus 5x plus 6x minus 15 equals 0. And then we will start factor by grouping. I'll take out a GCF of the first two terms. And then I'll take a GCF out of the second two terms. I know I did my factor by grouping correctly because now I see my parentheses there are the same. So my factored form is going to be x plus 3 times 2x minus 5 equals 0. Just a review of factoring when a does not equal 1. So there's my factored form. I can solve this. I'm going to get, do the zero product property. We can set these both equal to 0. And I get x equals negative 3. And then I'm going to add the 5 and divide by 2. We'll get x equals 5 over 2. And so these are my boundary points. Those are my x-intercepts, okay? And now we want to figure out, this is our step 2. We'll plot the boundary points on the number line. So then step 3, we're going to complete the sign analysis. So what I want to do, I'm going to have some more room. Let's make it's just a rough sketch of a number line. And I'm going to do plot negative 3 here and 5 over 2 here. And our sign analysis is I want to test a number less than negative 3, a number that's over here, a number between negative 3 and 5 over 2, and a number greater than 5 halves. Okay, I need to test, that's our sign analysis. I need to test, when we call them test values, a number in each of these intervals, because remember, we're trying to figure out whether the graph is above the x-axis, greater than 0, or below the x-axis, less than 0. So those boundary points are the points at which it changes from greater than 0 or less than 0. And so we want to figure out our sign analysis is going to tell us whether it's a positive number, that means it's going to be greater than above the x-axis, or if I do my sign analysis and it's negative, it's going to be below my x-axis. And so what we want to do here in our sign analysis is we're going to use, just like in the steps said, we're going to use our factored form. And so I like to rewrite it down here, x plus 3 times 2x minus 5. And this problem was greater than 0. And I'm going to pick a number in each of these intervals. So less than negative 3, I'm going to pick, what number did I pick? Negative 5. Could be anything. We'll all get the same thing. And then I'm going to pick a number between negative 3 and 5 halves. I always like to pick 0 when I can. And then I'm going to pick a number greater than 5 halves. I'm going to pick 5. Like I said, you could pick any number less than, in between, or greater than these numbers, these boundary points. And so what we're going to do now is substitute these test values into our factored form and see whether we get a number, a positive number or a negative number. And that's all we're interested in, just the sign, not the number, because we're just trying to figure out if it's above or below, greater than, or less than 0. So when I substitute negative 5 in, and watch, you can actually get a number here, but you don't have to. I just literally am interested in the sign. So in my head, I'm thinking about negative 5 plus 3. That's going to give me a negative number. I don't even get the number. I'm just interested in the sign. And then I'm going to substitute negative 5 in for this x. So a negative number, negative 5 times 2, that's going to give me a negative 10. Negative 10 minus 5 is going to give me another negative number. And then I know a negative times a negative gives me positive. And so I know That's the first step in my sign analysis. I know all numbers less than -3 are going to give me a positive number, a number greater than 0. So I know I'm above the x-axis. And I have to do that for each of these test values. I'll do it again for 0. So if I substitute 0 into my factored form, 0 plus 3, I'm going to get a positive number. If I sub times 0 into the 2x minus 5, 2 times 0, 0, 0 minus 5, that's going to give me a negative number. And then I'm multiplying those two together. Positive times a negative is going to give me a negative. So then I know any number between -3 and 5/2 is going to be give me a negative number below the x-axis. And then I'm going to do one more time for the test value of 5. Substitute 5 into the factored form. So 5 plus 3, that's going to give me a positive number. And then times, I substitute 5 into the second factor. I'm going to get 5 times 2, 10 minus 5 is going to give me a positive number. Positive times a positive is a positive. And that's my sign analysis. This is what we're interested in looking at. Here's my number line. And I can see where this polynomial is greater than 0. My answer lies right here on those positive intervals. So then when I write my answer in interval notation, which we've done before, think about when you write domain and range, that's in interval notation. So everything less than -3, so that means my answer is going to be from -infinity to -3. And then we use the union symbol. Or my answer could be from 5/2, all right, 2.5 to infinity. And that's my interval notation, that's my answer. If we want to write my answer on a number line, I'll have -3 and then 2.5. And we'll have this like, oh, looks like a parenthesis. Everything less than -3. And then that parenthesis again for everything greater than 2.5. Okay, think about like the open circle, closed circle. We use that parenthesis if it's a bracket. We'll use a bracket for a closed circle if it's or equal to, which we'll see an example of. Okay, so lots of steps here. We'll break it down. We're going to do 2 more examples. That's your example of a sign analysis. Hopefully it'll make more sense when we check out another example. Send me any questions in the chat. I'll zoom out a little bit so you can see all of our work. And then we'll check out another one. Okay, so here is the, oh, let me show you this. This is the graph of, I meant to put this up. So here's that function, the one that we just did, 2x squared plus x minus 15. When you graph it, that's what it looks like. Notice here's those boundary points, -3 and 2.5. And we wanted to figure out where this polynomial was greater than 0 without looking at a graph. So we found those boundary points by solving the polynomial for x. And then we needed to test above and below these x-intercepts. And when we did that, notice we found that it was positive for values less than -3 and greater than 2.5. And that's what it looks like visually. So you can check your work on a graph. As long as it's above that x-axis, that's where it's greater than 0. Below is less than 0. Okay, let's check out our second example here. So we've got number 2, x squared minus x is greater than 20. And so first thing we want to do, solve for x, get everything on one side. So we'll have x squared minus x minus 20 is greater than 0. This is a quadratic. I'm going to factor it. So I'm going to have x minus 5 times x plus 4 greater than 0. And then right away, I know if I do the zero product property, my boundary points are at x equals 5 and x equals -4. Those are your x-intercepts. And now I need to figure out whether this polynomial, we need to figure out where it's greater than 0. So that's when I go to do my sign analysis. I'm going to draw a rough sketch of a number line, and I'm going to put -4 on and 5 on. And then I'm going to pick my test values. So my test values, I need a number from each part of this number line. Something less than -4, something between -4 and 5, and something greater than 5. So I'm going to pick -5 is less than -4. I'm going to pick 0 for in between -4 and 5, and I'll pick 6 for greater than 5. And we'll do or test those numbers in our factored form. Okay, so if I put in -5, so -5 minus 5, that'll give me a negative. -5 plus 4, that'll give me a negative. Negative times a negative is going to give me a positive answer, which is good because I want to know where it's greater than 0. Positive answers are greater than 0. Let's test 0. So 0 minus 5 is going to give me a negative. 0 plus 4 is going to give me a positive. Negative times a positive gives me a negative. Negative, all numbers, if I could have picked anything between -4 and 5, it was always going to give me a negative value. And then I'll test 6. 6 minus 5 will give me a positive answer, times 6 plus 4 is going to give me a positive answer. Positive times a positive gives me a positive answer. And so now when I look at my number line, I know my answers where they have to be greater than 0 are right here and right here. And so when we write that in interval notation, we're looking at numbers from -infinity to -4, union, or numbers from 5 to infinity. And we can write that on a number line. If I want to graph my answer, I will have -4 here, 5 here. That parenthesis looking, I'm going to call it a bracket, but it's a curved bracket. Everything to the left of -4, and then everything greater than 5 would be my my answer on a number line. If they want you to graph your answer on a number line, that's what it would look like. If they want your interval solution, interval notation, that'll be what it looks like. And then one more example we'll go through. Here it is, number 3. We have x cubed plus x squared is less than or equal to 4x plus 4. First thing we want to do, get everything on one side, so 0 is on the other side. I'm going to get everything to the left side to keep that leading coefficient with the highest degree positive. So I'm going to have x cubed plus x squared minus 4x minus 4 is less than or equal to 0. So here's our first one where we have an or equal to. And it just changes when we write our final, just impacts when we write our final answer. So I've got 4 terms. Let's see if factor by grouping is going to work. So I'm going to take out a GCF of my first 2 terms. We'll be left with x squared times x plus 1. GCF of my second 2 terms, I can take out a -4, and I'll also be left with x plus 1, so that's 0. And then I'll have x squared minus 4 times x plus 1 is less than or equal to 0. And let's just double check, can I factor anything further? And I can. That x squared minus 4 is a difference of squares, so that can be broken down to x plus 2 times x minus 2, and then we'll still have x plus 1. It's less than or equal to 0. Sometimes we forget that. Actually, a couple of students forgot to do a difference of squares to factor that. So always check to make sure your final factored form can't be broken down any further. And so now you'll see my boundary points are, we have 3 this time. -2, +2, and -1. Those are the boundary points where this polynomial intersects the x-axis. And now we'll go to do our sign analysis on the number line. And I'll have -2, -1, and 2. And we'll pick our test values, something between each of these numbers. I'm going to pick -3 or less than -2. I'm going to pick -1.5 for between -2 and 1. And I'm going to pick 0 between -1 and 2. And then I'll pick 3. And we are going to substitute these test values into our factored form of the polynomial. And be careful here, we're interested, like my final answer, we're interested in when it's less than or equal to 0. So I'm actually interested in where it's negative this time. Notice all the times before we were interested where it was positive. Notice that one I circled where it was positive because it was greater than 0. Okay, so let's substitute our first test value, -3. -3, if I substitute in for x, -3 plus 2 is going to give me a negative number. -3 minus 2 will give me a negative number. -3 plus 1 will give me a negative number. When I multiply three negatives, negative times a negative gives me a positive. Positive times a negative gives me a negative at the end. So here's a negative. This might look like. There we go. Let's substitute -1.5. -1.5 plus 2 will give me a positive. -1.5 minus 2 gives me a negative. -1.5 plus 1 will give me a negative. Positive times a negative is a negative. Negative times a negative gives me a positive. That interval would be positive. Let's substitute in 0. 0 plus 2 will be positive. 0 minus 2 will be negative. 0 plus 1 will be positive. Positive times a negative is a negative, times a positive is a negative. That interval would be a negative number below the x-axis. And then let's substitute in 3. 3 plus 2 would give me a positive. 3 minus 2 would give me a positive. And 3 plus 1 would give me a positive. Multiply 3 positives together, we'll end up with a positive. And so now where am I looking for my answer? I want to know where this polynomial is less than 0, is a negative number that happens here and that happens here. So my answer to this polynomial inequality in interval notation is everything less than -2, from -infinity to -2. And I have a bracket here because it's or equal to, or everything from -1 to +2. Again, I have brackets because of the or equal to in the very beginning of the problem. And if I want to write this or draw this, my answer is on a number line. I'll have -2, -1, 2. I will have a bracket instead of that parenthesis we were looking at earlier and shade everything less than -2. And then I'll have brackets from -1 to 2 and shade everything between. Here's my interval notation answer and then also my number line answer. Okay, lots of steps, easy math in between all of the steps, but it shouldn't be too bad. If you guys have any questions, let me know. Great work today, guys.